So now we're going to go ahead and get into special right triangles. These are called special right triangles because they are right triangles that have special properties which make our lives easier. So, mainly yours, but a lot of mine. So we've got two main right triangles that are considered special right triangles. We have a 45, 45, 90 triangle and a 30, 60, 90 triangle. Now, the sum of all the angles of a triangle are always 180 degrees. Always get 180 degrees. Therefore, when you look at these are perfectly related and these are perfectly related. And then they follow a pattern. So this pattern is found by the knowledge that two triangles make either a square or rectangle. If you can see, I've got that placed into there. Now, a 45, 45, 90 triangle, that is a square when you have two of them. You can see that is perfectly cut in half, therefore the sides will be perfectly measured. So the sides for this, for any value of x, so any scaling that you are looking at, it is x, x, and x root 2. Now where your theta is, that depends on the problem. So what you need to know right now is that 45, 45, 90s, across from each 45 is an x, and across from the 90 is x root 2. I'm going to go ahead by proving it with 1. So, say my x equals 1. I want to prove that that's true. So if I have a side that's 1 squared, and I have another side that's 1 squared, we're going to call this our hypotenuse squared, because we want to prove that it's true. This is 1 plus 1 equals h squared. 2 equals h squared. Take the square root, and h equals root 2. Now, if you look up here, it says x times root 2. Our x is 1, and so technically that is correct right there because that is an invisible 1. Now, hopefully that makes sense. Now that I've proved it, you just need to memorize it. Hard work's done. Next thing we have is a 30, 60, 90. So if we have it like this, it's a rectangle. And this can be built in order to prove this. I'm just going to go ahead and give it to you guys so you don't have to prove it. So across from the 30 is x, across from the 90 is 2x, and then across from the 60 is x times root 3. Now, I'm going to have the link to the proof, if you are curious on how it works, down below underneath the video. But for now, that's all you guys need to have, and that's what you need to know. And we're going to start to get into solving trig functions for any special right triangle using these properties. So, head to the next slide or the next couple slides, and we're going to get into working with these.